Okay, guys. All right. So what we said, what's the problem now with the previous design? The carry. So if there is a way to somehow we can find the carry in earlier stage, it will save us a lot of delay, correct? So now let's think about what we can do here. Oh, all right, what we have. Okay. So one of the other fundamental, I mentioned that before, any complex logic with multiple level, you can represent it by only two levels, by expanding the equation. So for example, let's give you an example, then I need you to help me with make it from multiple level to two levels. Let's say we have a function. Let me write it here. So if I have function, let's say A or B, and C, is that how many levels? That's one. And make it D, for example. So what we can do in this case, how you expand that? So now, before, let's draw this circuit. How you draw the circuit? So it's gonna be OR A and B, A, B, OR. Then you AND it with C. So that's C. Then finally you AND it again with D, correct? So how many levels we have here? Three levels. What's the delay? 3 delta. So now the delay is a 3 delta here. Now, can we represent this one to 2 level? Yes. So how we can represent this one to 2 level? So you expand your equation. So now what you can do here, the C, you add it, you multiply it by this 2. So it's going to be AC or BC, correct? And with D, correct? Now let's do another expansion. So what you can do, it's going to be ACD or BCD. So that's the equation. How many level this equation? If you want to do that, it's 1 OR and 2 ANDs. Correct? And you will have 3 input and 3 input here. Perfect. So how many level? What's the delay here? 2 delta. I'm sorry, 2 delta. So that's one of the fundamental, concept in digital design. Any complex digital design circuit, you can reduce it to 2 levels. All right? So that's one fundamental. So you expand your equation to 2 levels, ORs and ANDs, and you put them together. Why we do that? What's the reason behind that? To reduce the delay. So now you will have less levels by just converting your equation to only 2 levels. So now how the delay will be 2 delta. Clear? All right, so that's fundamental. I will see why we need that. All right. Now we already compared that about how to what's the smart the 2-bit. So how much we say the delay here for the only using the K-map, the fast adder? Remember we said 2 delta, correct? Now what if we use the slice approach for only for 2-bit adder? How many slice we need? Correct, we need 2, and the carry, and you will have the carry input here. So what's the delay here? 3 delta. Remember we say 3 delta, and you will have here 3 delta. So what's the speed, the delay here? Total 6 delta. 6 comparing to 2. That means the circuit is slower. But again, what's the problem? if your design or your input more than 6, it's going to be a problem. You cannot use the K-map. You have to use the slice. So that's how we compare it. So the slice approach now, it's a slower. Doesn't make sense then to use it. Now, can we improve that? Yes. As we said, we have to find a way to break that carry. We have to make sure the other slice somehow not dependent on the carry. We don't have to wait for the carry to finish, the carry out finish before it goes to the next stage, correct? So that's why we have a approach called look ahead. So you look ahead, find the carry before, and then you do everything together. And how we can do that? I already explained that to you, this equation, the delay, correct? I want to do it again and convert it to two level just to refresh your memory again. Since I have it here, I gave you another example. So how you expand this equation? Just let me know. AC and BC, correct? And if you add or, correct? Or D, correct? Then you will do E. Now, how you expand that again? Okay, that's or, so that's fine. Then you will just add the E. So it's going to be AC or E, BCE, and DE, correct? Now, how many levels now? How many levels here first? No, this one, how I will draw this one? I'm sorry, this one. How we draw this one? So you will do A, B, you do OR for them. Then you end it with C. Let's say that's C. Then you OR it with D. Then finally you end it with, correct, E. So how many levels we have? 1, 2, 3, 4. So what's the delta? Delta equal 4. Okay. So now how we reduce the delay? Using the concept of expansion, right? So if you want to expand, we expand it here. And how you draw that? Again, it's going to be AND with 3 input, another AND with a 3 input, then finally another AND with 2 input, and all of them OR together. So what's the delta here? All right. So again, the theory here, any complex, I need to keep that in your mind. Any complex digital circuit, you can, reduce it to 2 level, and which is mean the delay will be 2 delta. All right. Let's go now. That's very important topic. Is there a question before we go to the look ahead approach? No. So now, how we kind of break the relation between, or the dependency between carry 0, carry 1, and carry 2, and carry 3. So what we can do, we can try to represent each carry using the previous one. For example, what you can do, if there is a way to calculate the carry 3 using numbers and C2 somehow to find the answer. Same thing, if there is a way to find the carry 2 using the carry 1. And same thing, when you do carry 1, find it through C1. And C1 uses the C minus 1. What that mean? What you're trying to do here, you're trying to substitute the carry from the previous stage. So you carry 3, you remove the equation and somehow you embedded the carry 2 inside. So we'll see what we mean by that. So in the carry ahead, there is 2 concepts. There is something generation, what they call generation of carry. Okay, and the other one propagation of carry. And we'll give you what we'll show you what's the difference. What's this mean of generation of carry? You know, let's say you have a number, you know, it's 4-bit, 8-bit, doesn't matter. Let's take, you know, any two numbers, you're trying to add them, and look to one of the stage. This one maybe stage 0, 1, 2, 3. We don't care which stage. Now, what is the condition? Okay, that's the carry out equal 1 without and if the carry n equals 0. Okay. So again, let me repeat it. What is the condition? Your carry out will be 1 if your the input carry equals 0. 1, 1. That means you generate the carry in this stage. So the carry is not coming from the previous stage. So that's, they call it generation carry. So that the carry generated in this stage. And that's happened only in one condition, when both of them is 1s. Because the carry, if the carry coming from a previous stage, that's not generation. That's propagate from the previous one. Okay, so that's the first condition. And it's only one condition here. When both of them is 1, when A of I equal 1 and B of I equal 1, and this one we said always has to be 0, then we will have a carry, right? So in this case, what's the equation here? If you want to do a right equation for that, okay, GI equal A of I, B of I, correct? So if this one 1 and this one, what the result? 1. If any one of them 0, the result will be correct 0. So that's the equation of the GI. So the generation of carry, it's an AND gate. All right. So you will understand that later, you know, but keep that in mind. That's the generation. Now I'm looking how I can generate the carry in this stage if I don't have any carry before. I did not receive any carry. So that's happened on only one condition, when A and B equal 1. That means I generate the carry in this stage. All right. So now let's go to the other concept, which is the propagation carry. What that means? I will ask you the question again. When I will have a carry equal 1, okay, if my carry from previous stage equal 1, when is the condition? Or 0, 1. So if one of them, if A or B equal 1, that means I will have a carry generated, not generated, carried or propagated to the output. So for example, again, that's clear. I'm asking now, let me repeat that again. What's the condition for A and B? So you will have a carry equal 1 if your carry input or the previous one it's equal 1. When is the condition? The condition if A or B equal 1. For example, here. Now let's say, you know, my input here is 1. That's an example. Is there a carry here? No. So the sum will be 1 and the carry will be 0. Okay, so that will not work. But now let's take this condition. And again, I'm talking, you know, when I have always 1, I have a carry from the previous state. So when is the carry? We will have a carry if one of them is equal 1. So 1 plus 1, 0, and carry 1. Correct? Now, what if we do the opposite? If this 1 and this 0, what's the result will be? It will be 0 and carry 1. What about 0, 0? 1, no carry. And I don't need this condition. I'm looking only for the condition the carry is equal 1 when I have a carry from the previous stage equal 1. What about 1, 1? 1 and equal 1 and carry 1. So, and that's, you know, will not work with us. So What's the equation for that? It's going to be the BI equal A of I XOR B of I. All right? So now what we found, again, we find the GI. Yeah, then the which one? Okay. Yeah, but that's you generate internally. Remember the first condition we say when both of them is 1? So we know only we're trying to find the propagation condition. Now, when both of them ones, what that mean? It generated in this stage, and we do not do that. So that's why I'm trying to separate between the generation and propagation. Okay, clear? So we find now the equation for the GI and B of I, correct? That's the first step, and we'll see why. You know, if you understand 50% so far, that's good. You know, you don't have to be, scared. Now the question now, can now we represent the sum and the carry using the BI and GI? Yes, correct. So again, what we have so far, we say the GI equal A of I, B of I, right? What about the BI equal A of I XOR B of I? Perfect. So when we did the one slice, what's the sum equation? Remember the sum here? Remember, it's A of I XOR B of I XOR C of I. What does mean? What this one? B of I. It's simply, I'm sorry, it's simply B of I. So what's the new equation will be? B of I XOR C of I minus 1. Now I just removed the XOR and I added the B of I. All right. So now what about the carry now? So that's the old equation. What we have there? A of I of BI, what this one? It's simply G of I. So that's why it's changed to the G of I. Correct? Then you will have, or C of I, will leave it as is. What you have here? What is the X? A of I XOR of I? It's P of I. All right. So what we replaced, the full equation using the B of I and the G of I. And we'll see why. All right. So now what's the final two equation we have, guys? You have to keep that in your mind. So the sum of I now, it's equal what? B of I XOR C of I minus 1. And the carry I equal G of I, or, correct? C of I minus 1, then BI. There is not, just like this, correct? And you will understand now when we expand it, will be much easier and reasonable what we are looking for. Now, okay, let's find some numbers here. So that's two equations, correct? And if I want to find sum of 0, what we have to do? Just remove I, put 0. I'm not doing anything magic. So what's the sum of 0? It's going to be B of 0 XOR C of minus 1, correct? But if you want to do sum, I'm just repeating what I have here, but I'm trying to write it for you, just make it easier. Sum of 1, it will be equal P of 1 XOR C of 0. Perfect. If you want to do sum of 2 equal B of 2 XOR C of 1. Sum of 3 equal B3 XOR C of 2. Simple. So that's the sum. All right. Now let's do the carry. Okay, what's the carry we have? It's G of I, which is G of 0, and, or C of minus 1, B of 0. What about C1? It's going to be G1 or C0 B1, C1, sorry, C2, G2 or C1 B2, C3. What's the C2? G3 and C2 B3, right? So if you remember what we said initially, you say, you know, if there is a way to find the CI using the CI using the previous one. So if you see here C0, and we used the previous one in the equation. Clear so far? Right. By the way, in the exam, I'm not going to ask you to write this stuff. You know, it's going to be much easier. But that's the process, how they find the look ahead, you know, design. What's the purpose of that? That's the next step. Good. Now, what else we can do here? So you want to, you know, let's draw the circuit. This one is gonna you know, change, but you know, let me, can I do it here? I'm sorry, let me just try to expand that here. So now let's, you know, let's do just only the first one. So the sum of 0, what's the sum of 0? Remember, the sum of 0 is yeah. I'm not sure where I want to draw that for you. Can we do it? All right. I will try to make it similar, unless if I do another page. Okay, so now let's remember that. So let's do a circuit for the first block. We now, let's say, you know, the level 0 here. I'm gonna write it 0. So what is the G of I? How it's gonna look like? It's simply it's AND, correct? It's AND gate with A of I, A of 0, and let's talk about stage 0. So that's the G of I. What about the B of I? It's gonna be XOR, and that's the B of I, correct? And XOR of, sorry, A of I and XOR B of I, right? So that's really just how to find the G of I and B of I. So that's G of, I'm sorry, that's G of 0, and that's B of 0, all right? So I'll talk about the first stage, right? Now, what is the sum? The sum of 0, it's B of 0 XOR C minus 1, correct? So you will have XOR here. I'm sorry, XOR, which is B of 0. And what you will have? Most is going to be ground, the first one. It's going to be C minus 1. I don't like that. So let's go to another tab. Okay, so let's make it more clear. That is A of 0 and B of 0. And you will have and that will give you the G of 0. And you will have XOR, and that will give you B0, correct? And you will have A coming here and A coming here, then, all right? Now, what is the sum? Sum of 0? It's going to be XOR with B of I and that's C of I minus 1, correct? And that's the sum of 0. So usually what we do, we do with the XOR here. And I'm going to try to make it match what we have there. So it's going to come like this, right? And this one coming from outside word, which is C of I, correct? Now, what is the carry? What's the carry equation? G of 0, or it with C of I and B of 0. So first we have to do AND for C of I and B0. So if you go back here, you will do AND with C of I, correct? Then we will do OR with G of 0. So that is the C0. Clear? So that's the first one. That's the first cell. Now, if you want to draw the second cell, how that's going to look like? You will have AND, because that's, remember, that's a cell, what they call it, slice approach. That means you will use the same design. So you will do design once and just move it there. So you will have AND, you will have XOR, all right? Then you will have A1, and you will have B1. Okay, A is going here, and B is going here, and B is going this way, and this one is going here. What we'll have here? You will have G of 1, and you will have B of 1. Perfect? Then you will have the same circuit. You will have an AND here, and it's going to an OR, and this one is going to give you carry 1. Then how you connect that? It's going to be, and this one AND is going to go from here, and it's going to come from the carry, from previous carry, and this one is coming from G of 1 here. All right. Then same thing. You will take this one here. You will have XOR. XOR with the carry. So you will take the carry here, and we'll go here, and it's going to go here, and this will be sum 1, and this carry 1. All right. Same thing. You will do the third stage. Same design. The only thing is, you know how you connect it. Let's go back. So if you look at the design, you know, that's just to find this block. What does the block do? What does the block do? Just to find, no, but I'm talking about this one here. That's just to find the G, I, and BI. And that's for stage 0. So that's why it's going to give you the G0 and B0. And this one, it's going to give you G1 and P1. Here it's going to give you G2 and B2. And here will give you G3 and P3. Perfect. So that's the block. Then after that, you add the second layer here. That's the actual equation, you know, from here, from this equation, and from here. How we can find the sum. Clear so far? Okay, so now let's talk about the delay. What's the delay? Now to find first of all, what's the delay here in the GMB? 1 delta, correct? It's me. So here we'll have 1 delta. Why? Because it's only 1 level. Perfect. To find the carry, how many delta? You will have another one here, another one here. So the total will be 3 delta. Perfect. I'm sorry. What about the sum? This sum. What is the delay? Why? Because remember the sum, it's relying on this line, which is coming from here, and it's coming from here. One, oh yeah, so one here, and you have another one here. We will have 2 delta. Okay, that's only the first stage. All right. Now let's talk about the second stage. The second stage, how many delta you need? So you will have 2 here, correct? No, but before you will have here 2, correct? But remember, we need this carry. You see this carry? We have to wait for this one to come. And this one is going to come us after 3 delta. So I have 2 plus 3, then you will have 5 delta. And if you see 3 delta, 5 delta, then this one it will be 7 delta. This one will be 9 delta. All right. The sum is going to come before. Remember that here it's 5 delta. Here it's going to show after 4 delta. Here it's going to show after 6 delta. All right. So what is the total delay here? 9 equal this. Okay. So comparing to 9 delta to 12, there is improvement, right? We did some improvement. Is that enough? No, of course no. We should improve it more. So in this stage, what we did so far, we just try to find a way to calculate the carry fast, because our problem with the carry. So this way we've been able to use that B and G to decide, when we would have carry and when we would not have carry. Now, can improve that? Yes. How we can improve it? By what? I want to go back to this equation. Again, our concern about the carry. So this equation, can somehow I replace something and make it more expanded and make it more simple? Okay, C0 equal G0. Is there anything before G0 we can calculate? No, that's stage 0. We cannot do anything in this stage, all right? What about C minus 1? That's coming from outside. B0, that's the first stage. We cannot do anything. Now let's talk about this one, C1. What we can do with the C1? You see C is 0? Can we replace C0 by this equation? Since we have it, can we do that? So what we can do, how that's going to change? If C1 equal G1, correct? Or what is the C0? It's going to be G0 or C minus 1, B0, and do B1, correct? That's what we did. Now, can we expand that? Can we expand it more? Yes. How we expand that? So it's C1 equal, it's going to be G1, or just we have to multiply B with everything. So I will see G0 B1, or let me make it different. Okay, now let's do it this way. So then, or what we can do, it's going to be, okay, it's going to be B1, B0, and C minus 1, correct? So what that means, if you read this one, what that means? So we will have a carry. I need you to think about it. So when we will have a carry at stage 1? You have a three conditions between and or, correct? You have or between three terms. So you will have a carry at stage one in three conditions. First of all, either we generate it at the same level, correct? At the same level, if A and B 1 and 1, I will have carry, correct? Or what I will do, it will be either generated in stage 0, generated in stage 0, and it's propagated to stage 1. Or either it's coming from outside, C minus 1 is coming from outside, and a propagated from B0 and then a propagated to B1. So that's the purpose. So either you have a carry in a three condition, either I generated in my stage, I generated that's in A and B is equal 1, or the previous stage generated and propagated to my stage, or even the stage before you generated in the stage 1 or 0 and propagated from stage to stage. So that's the whole idea of that. So what that's mean? That's mean, I will have a carry. Where's the circuit? Okay, that's mean I will have a carry, for example, here in this stage, if I generate it here. So if I have 1, 1, then I will have the carry equal 1. Or I generate it here, then I just transfer it to here. Or I generate it here, then I transfer it from here to here to here. Okay, that's carry 1. Now what about carry 2? How we can rewrite the carry 2? So that's the carry 1, correct? Now can we do the carry 2? How we do that? Okay. Let me. I have it written somewhere, so I'm gonna delete that. Delete. I wanna delete it. Oh, all right, that's fine. I can use this equation here. All right. So now I wanna transfer this one. So C2 equal, just give me a hint. So it's gonna be G2, correct? Or what? What's the C1? Here's the C1, correct? What's the C1 is G1 or C0 B1. Okay, all of them is B2. All of them is B2. Perfect. Now let's expand, correct? How you expand that? C2 equal G2, then or B2. Let's make it G2. I'm sorry, no, G1. I'm sorry, this one, G1. This one, if I can delete, okay. This one, it's gonna be G1, then B2, or B2, B1, then C0, correct? What else I can do now? Replace C0 with. All right, so now what I have to do now, this one will be equal. I will leave G2 or G1, B2, or, okay, I will do B2, B1. What's the C0? It's going to be G0 or C minus 1, B0, correct? So that's the equation. Now, what else we can do now? Let's expand. How we expand that? Now I did that, so I'm going to delete it. All right, let's expand this one. Yeah, I need your help. So C2 equal G2 or G1, B2, or, okay, now, we will okay, we will multiply, so it's gonna be G0 B2 B1, correct? Or then C minus 1, then B2 B1 B0, correct? That's our equation. What that means? So we will have, that means we will have C2 equal 1 when we'll have the C1, or sorry, C2 equal 1. When we'll have it? When we generate it at the same level, all right? Or it's got generated in level 1 and propagated to level 2, or generated in level 1, where's the G0, and propagated through B1 to B1, B2, and finally, if it's coming from outside, and propagated from level 0 to 1 to 2, right? Now, if I ask you to write C3 for me, do you think I have to go through the expansion again? No, if you think about it, so how you will write the C3? You want to do write C3, just help me. If I want to find C3, when I will have C3 equal 1? If I generated at, which is generated at level 3, or where? Or I generated in level 2 and propagated to level 3. Perfect. Or generated level 2 and propagated to level 2 to 3. Perfect. Because you generated at 2, I'm sorry, you generated at 2 and then you propagated through 2 to 3. Perfect. Then what else we have? If you generated at level 1, then you propagated from B1 to B2 to B3. Then finally, if you generated at level 0, okay, and you propagated to, okay, B3, B2, B1, B0. But here, we're not generating, that's coming from outside. So that's how it's going to look like. So that's really the concept. That's the whole idea. All this process just to see how we can generate carry. All right. Either you can generate it at your stage, or it's coming from the previous one, or from the previous one, or from previous. So that's how we do the circuit. Now, what is the next step? Okay, the delay went down from 12 to 9. Is good enough? No. So we have to reduce it more. We did that already. We did expand. We already did that, this part. So we found Z0, C1, C2. Okay, now what is the delay now? Remember, now when we did calculate the Z0, 1, and 2 to 3, what exactly happened here? That's mean I can calculate all of them in the same time, correct? So in the same time, I can build a circuit to find carry 0, 1, 2, 3, which is really killing us, which is stopping us from to finish the design or getting the result faster by creating something called carry look ahead. You do that math in one shot. You will have the carry 0, 1, 2, 3 in the same time, right away. All right. And when we talk about digital design for any complex design, what is the delay for any complex? When you reduce it to 2 level, it's 2 delta, correct? What that's mean? That's mean just to find the carry, it's gonna cost us 2 delta. Then you need another delta for the sum, right? So if we see the design here, full design, all right? Okay, so How much you need to create the G0 and G1? You need 1 delta. 1 delta, correct? Now for the carry ahead, let's say that's the carry ahead circuit. What is that? 2 delta. So how much to get the G's and the carries here? How long it's going to take from you to calculate them? 3 delta, because you have 1 and 2. Then after that, you will have all of them. Perfect. Then what you need else? You need 1 for the sum. Correct? So how much the total we need? 2 delta. So how much the total delta we need for? So you need 1 delta here, correct? So how much total you need for the whole circuit is 3 delta. Is that good enough? Because remember the sum, we got the sum right away from here, after the 3 delta. Actually, you need 4 delta for the sum, because still you're waiting for the carry, correct? So you need the carry. So 3 plus 1 is 4. So the total delay for the whole circuit is 4 delta. All right. So before, was the delay? 9. We reduce it to 4. Is that good enough? Is that good enough? It's not good enough. Yeah, we'll try to improve it more. So, but we'll continue on that. So now, based on this circuit, we have higher speed, correct? Less delay or delta and high speed. What is the cost of that? What is the cost? What's the cost? You have high speed, but there is a cost always. You improve something, we improve the delay. We fix the delay. We improve. Huh? Gates. Why? Because we did the expand. All right. Now the question for you. Now, if you have 8-bit, first of all, now if you remember when we do the expand for the C2, where's the C2? Okay, for the C2, actually, where's the C3? Make it easier. I'm sorry, here. Remember the C3 here? That's what? AND gate, correct? That's AND gate. How many input for this AND gate? We need 1, 2, 3, 4, 5. So that's 5 input AND gates. Now let's say I want to do. Now we're talking about only 4-bit adder. Now let's say I want to build the same circuit for 8-bit. What's going to happen here? Remember, for 4-bit, we had to build gate with 5 input gate, correct? Now with 8-bit, we have to use some of the gates. It's going to be 7 or 9 inputs, because 8-bit, okay, and it will have 9 inputs. So it's going to be 9 input. 9 inputs. Usually when you do 9, you will know that. So it's 9 inputs, correct? What about if you want to do 16-bit add? So that means you have to use a gate with 19, oh, I'm sorry, 15 or 16, 17 inputs. Okay. So now in digital design, okay, that's you will learn it in another course. It's called VLSI, when you do the actual designing of the chipset. So in VLSI course, for very large scale circuit, correct? Yeah. So if you study that, it's kind of part of the logic to find the delay and from gate to gate. And if you have bigger size, okay, what they found, when you have gates with more than 5 inputs, the delay will start increasing. So for example, if the delay for 4 input, it's 1 delta, okay, when you add another input, it's going to increase from 1 to 1.2. And if you add more, it's going to slow more. So to get to the point, is not recommended, and nobody using that, to use gates with more than 5 inputs. All right. So in this case, can I build 8-bit adder using this approach? Can I do 8 and with one 8-bit look ahead carry, or look carry ahead, or look ahead, look ahead carry circuit? Can we do that? So you cannot do that because you get to the point you're not speeding the process. You're slowing down the circuit because the gates, it's going to slow. When you have more than 5 input to gates, then your speed is going to slow down. So in this case, there is a limitation. We cannot use, more than 4-bit look ahead. Now how we can build 8-bit? So what we can do, correct? So another solution. Now we just finished designing the 4-bit. So we created 4-bit adder, correct? Using what? You will have here a carry look ahead, correct? That's only 4-bit. What else we can do? Can we add another one here with 4 input? So this one, let's say, that's A from 3 to 0, and this B from 3 to 0. What's the output here, guys? It's going to be sum from 3 to 0, and you will have carry, correct? Carry 3, 0, 1, 2, 3, correct? Now let's say, I'm using A from 4 to 7 and B from 4 to 7, correct? So that's the number. So how many bits that? Okay, what's the output here we'll have? The sum from 4 to 7, and you will have the carry out, carry 7. So how we can do that? Simply what we can do, we can just take this one and put it as an input. But now what's the delay? So how much the delay here we said 4 delta? Now what's that delay now for the whole thing? It's going to be total 8 delta. Why? Because we have to wait until this one, until C3, finish after 4 delta. Then you have already 4 delta here. So here it's going to take 8 delta, correct? To find the C7. So it's still good, all right? Because, if you want to use the regular method where you slice and you just do carry to the next stage, it's going to take 24 delta, correct? But now from a 24 to 8, 24 went down to 8. That's still good. But what else we can do? And how we can eliminate that? Simple answer, believe me. Think about it. Yeah, but what we did before to eliminate this one? So what we used? Correct? Now what else we can do here? Can we somehow, let me remove that. Remove that. I'm sorry. Remove that one. Just want to make sure Can we remove that? Can we use let's name it a block carry look ahead, and somehow we got the C7, C3 here and C7 here. Can we do that? And if you think about it, what's the circuit here? The circuit here is the same circuit as here. So when in the real design, you build only one carry look ahead, then you reuse it here, here, and here. We will go over it next class, but I'm telling you next time, but I'm telling you what we have. Okay. As we said, it's limited to 4 output because of the gate. And that's what we said, you can do 4-bit look ahead adder, 2 of them we can use them, and we do the carry. And the total will be 6 delta, right? I don't know why oh, that's for the carry, but for the sum, it's going to be 7 delta. All right. Now, and we said, can we cancel that? Yes. What we can do, we use another layer of the block level carry look ahead. And that's how we can do, for example, that's 16-bit carry look ahead. So if you have 16 carry look ahead, how many units we need? Because we built the 4 bits, correct? So you need 4 of them. So you will need 1, 2, 3, 4. And you will have 1 block level carry look ahead. And that's it's going to give you C3 and C7 and C11 and C15 at the same time. So, and how much the delay we said here? For the 4-bit? Let's say it's 4. Okay, and how much here? 2. And what's the result will be after? 6 delta. Can we expand that more? Can we do 32-bit look ahead? Yes, you can do. You can add another layer. The point here, we have to use only 4-bit adder. We cannot do more than that. It's going to be too big for the gates. All right. Is there any questions so far? We will go over this one more in details and show you it's simply the same circuit, the same design inside here. It will be, I'm sorry. So here you see CLA, it's going to be the same design as here. You have to reconnect it. What's the time? Yeah, I think it's kind of early, but any question? Anything we should repeat? So I will send you the assignment one, or maybe I will put in Canvas so you can check that. It's the time to ask. Is there anything else you need me to go over it again? Which one? Here. So now let's just delete that. Delete everything. Delete everything. All right. So now this one, to find the G's and B's. How many? What's the delta there? It's 1, correct? Because it's only one level. That's equal 1 delta. Now for the carry look ahead here, when you expand, when you build the equation and you expand it, what's the delay usually? 2 delta, correct? So now to get the carry 0, all right, how many you need? 3 delta. All right, what about the C1? It's going to take 3 delta until the C3. C3, what's the final? It's going to be 3 delta, correct? However, now for the sum 3, what you need? Because you need the carry from here, from C2. Remember, it's going here. So you have to wait 3 delta, then you need a gate here. So the total to get the sum 3 equal 4 delta. Because you don't forget the sum, the last sum, you cannot do even the whole sum. You have to wait for all the carries to come out. So with four carry look ahead units, we got the result after 4 delta. Okay, when you make it bigger, now again, if you wanna, that's 4-bit. Now, if you wanna make it 8-bit, remember this carry, it's gonna take 3 delta to finish. Perfect. Then this one starts, and to receive carry 7, you need another 3. So here it's gonna take 6 delta to finish. However, the last sum, you have the XOR. So this one, the sum, I would say sum 7, it's gonna take 7 delta. Correct? That's if we use that carry this way from the previous stage. However, if we improve it and we add another carry look ahead, what's the total will be? Remember here, to receive carry 3, how much took from us? 3 delta, correct? Then you need another 2 here. So to receive the other ones, I'm sorry, make it this one easier. To receive C3, okay, it's gonna take from you 3 plus 2, you need 5 delta here. 5 delta, 5 delta, 5 delta. However, the last sum, the sum number 15, what's the total will be? 5, 5, and you need 1, 6 delta. 4-bit. How much the 4-bit? With the carry ahead, the last one, 3 delta? Yes. So I'm sorry. So 3 delta. Yeah, where I'm going. Here you need a 3 delta to receive the last carry. Then you need 2. So this carry. Yeah. Oh, okay. I'm sorry. So when you expand it, you will receive C3, all of them in the same time. So you're talking about 3. You will have 3 from here and another 2, 5 total. We'll go over it. We'll go over it again. But so far, remember, we've been able to improve that from initially 12 to 9 to 4. That's a huge improvement. Let's see if we can improve it more. Any more questions? Now, guys, feedback from you. Do you like this way? You like to use the laptop, or you need the board? This one make it faster for me. If you want to write, it's going to take an extra hour. I'm trying to take a screenshot and I leave a space for me to write. Okay. After I fix my other laptop, even it will be easier because I will have it in Word document. So I don't have to go to OneNote. So I'm working on it. So hopefully next time even will be faster. I'm not trying to give you a lot of material. I'm finishing quicker because everything is there. It's listed. Just I have to explain stuff for you. And everything is recorded. So I will post on YouTube. I will send you the channel. Then you can, if you want to go review, you can review it. I will put the actual file, the main file before I write anything on it. I will upload it to Canvas, so you can download it and you can add what you want. Because I left a few stuff empty, for me to write it here. But if you want to go and try it by yourself, find the equation and write them there. That's gonna be a good practice. Unless, guys, if you need this copy, because I don't think so that's gonna work because I delete stuff. So I will give you the original one. And just if you wanna write stuff, you can write. If you wanna just read it as is, if you wanna use the video, it's up to you. Okay, guys, over Zoom, do you have any question before I end? Is anybody there, by the way? Thank you. There is 11, but I'm not sure if they are listening.